Alright guys, so in section 10.2 we're going to see our first method that we can use to help us solve quadratic equations. And it's going to be what's called factoring, which we've actually already seen. So in a lot of cases we can find our solutions, which just a little bit of vocab. The solutions are also sometimes called the roots, the zeros, or the x-intercepts of a quadratic equation by factoring instead of by graphing. Now remember, we have not taken a look at graphing this year, and that would have been Unit 9, and we kind of skipped over that. So this is going to be kind of our first way that we'll actually have seen to help us find solutions. So these are going to be our steps below, which can help us to find solutions to a quadratic equation. So step number 1 is make sure that the equation is set equal to 0, and make sure that the a value is positive. So as an example, we've got x squared plus 3x minus 10. Instead of it being equal to y, let's just say it's equal to 0. Now the a value, remember, is the number in front of x squared. We need that to be positive. In this case, it already is, as a positive 1. Step number 2, then, we're going to look for a greatest common factor first. For x squared plus 3x minus 10, there is no greatest common factor, so you can skip that part. But then we're going to factor using those skills that we did in Unit 8. So this is, if you remember, where we take a times c, 1 multiplied by negative 10. That becomes the top of the x. And then the 3 becomes the bottom of the x. So we need numbers that multiply to be negative 10 and add to be positive 3. So that would be 5 and negative 2. So then we'll go ahead and use our number that was in front of x squared, which is the 1. We'll put that above each of our two terms and look to see if we can simplify. And in this case, we cannot. So there would be our two factors, would be 1x plus 5 and 1x minus 2. Don't forget that the equation is equal to 0. In step 3, we're now going to use what we learned in section 10.1 to help us continue solving. Remember, that is where zero product property, we're going to set each of our factors equal to 0. So x plus 5 is equal to 0. And also x minus 2 is equal to 0. Then we'll go ahead and solve each of those factors. So on the one for the left, we will subtract 5 from both sides. That'll give us one of our solutions, which is that x can equal negative 5. And for the other, we'll add 2 to both sides. And that will mean that x is equal to positive 2. So notice step 4 is just to write those like we just did. You write x equals and then whatever the answer is for your final answer. And there would be your two solutions. Okay, so let's go and take a look at some examples of this. For our first example, we've got x squared minus 8x is equal to 0. We've only got two terms, so this is going to be either greatest common factor or difference of squares. Let's try greatest common factor first. Since both x squared and the minus 8x have x in common, we'll go ahead and factor out an x. That'll leave us with x minus 8 inside the parentheses is equal to 0. And now here's where we're going to use zero product property. So set your two factors equal to 0. So x equals 0 and x minus 8 equals 0. And then we'll solve anywhere we need to. Obviously for x equals 0, that's already been done. For the other equation, just add 8 to both sides. And we'll get that x is equal to positive 8. Okay. For our second equation, we've got x squared is equal to 25. So the first thing we need to do is we need to get our equation to equal 0. The easy way to do that is to just subtract 25 from both sides of our equation. So on the left side, that'll mean x squared minus 25. On the right side, 25 minus 25 is 0. And now we should be ready to go ahead and factor. Once again, we only have two terms, so this is going to have to be a special type. We'll look for a greatest common factor first, and there isn't one because x squared and 25 do not have anything in common. But we can now look for difference of squares, and in fact, they are perfect squares. So remember, with perfect squares, we'll take each of them and write what's being squared. So for x squared, that's just x times x. For 25, that's 5 times 5. And then make one of them positive and one of them negative. Now we're ready to go ahead and use that zero product property. So set each of those equal to 0. So that would be that x plus 5 is equal to 0. And also that x minus 5 is equal to 0. Now we're ready to go ahead and solve. So let's go ahead and solve each of our equations. For the one on the left, we'll end up with x being equal to negative 5. And for the one on the right, we'll end up with x being equal to positive 5. All right. So let's go ahead and take a look at our next example. On the next example, we've got 9x squared minus 64 is equal to 0. So this one's already set equal to 0. We can kind of skip over that first step. Next, we'll go ahead and see what kind of factoring we need to do. It's only 2 terms, so we'll check for a greatest common factor first. Both 9 and 64 are not divisible by the same thing, so now we need to look and see if it might be a difference of squares. And in fact, it is a difference of squares because both 9 and 64 are perfect squares. So we'll go ahead and set up our 2 parentheses. For the 9, that would have to be 3 times 3. For x squared, x times x. And for 64, 8 times 8. Remember to make one of them positive and one of them negative. Now we're ready to use zero product property from the previous section of notes. So we'll set both 3x plus 8 equal to 0 and 3x minus 8 equal to 0 as well. So then solving each of those equations, for the one on the left, we'll go ahead and subtract 8 from both sides. So 3x is equal to negative 8. And then divide both sides by 3. And we'll get that x is equal to negative 8/3. For our equation on the right, we'll go ahead and add 8 to both sides. That'll give us 3x being equal to positive 8. And then once again, divide both sides by 3. And we'll come up with x being equal to 8/3. Go ahead and leave your answers as fractions. Don't worry about changing them to decimals for these types of problems. And just leave them as, the fractions that are not mixed fractions. We don't want to have mixed fractions, so don't worry about trying to write them as like 2 2/3 or anything like that. Now, notice that the 2 answers are just opposites of each other. You have negative 8/3 and positive 8/3. Kind of like on the previous example, we had positive 5 and negative 5. And really, anytime you have a difference of squares like we have on these last 2 problems, that's going to be the case. You're always going to end up with answers that are opposites of one another. Okay. For this next example, we've got 75 is equal to 12x squared. So we need to get one side of our equation to equal 0. Normally we would subtract the 12x squared, but then we would have a negative 12x squared, and that's a negative in front of x squared. So instead of going in that direction, instead let's do this. Let's go ahead and just subtract 75 from both sides instead. So when we do that, now the left side of the equation is equal to 0. And on the right side, we have 12x squared minus 75. And so it does look a little bit different because now the 0's on the left side, and that's okay. We're still going to work it all the same ways. If it really bugs you, just take your equal 0. But just take your equal 0, move it over to the right side of the equation, and write it as equal 0 over there. It's really no big deal. Okay, so as far as factoring goes, let's look for a greatest common factor first. And with our 2 terms, both 12 and 75 are divisible by 3. If we take 12 and divide by 3, that's 4, so 4x squared. 75 divided by 3 is 25. And now we're going to look to continue factoring with what's inside the parentheses. So inside the parentheses, we still have 2 terms, no more greatest common factor. And so we're looking for possibly a difference of squares. And both 4 and 25 are perfect squares, so we should be able to use that method of factoring. For 4, that would be 2 times 2. Obviously for x squared, x times x. And for 25, 5 times 5. Now remember to make one of them positive and one of them negative, and now we should be ready to go ahead and use the zero product property. So we'll set each of our factors equal to 0, starting with the 3, and then the 2x plus 5, setting that equal to 0, and then finally the 2x minus 5, setting that equal to 0 as well. Obviously for the first one, 3 can equal 0, so that one just kind of gets tossed to the side. But for the next one, we'll go ahead and solve that. So we'll subtract 5 from both sides, so 2x is equal to negative 5. And now divide both sides by 2, and we'll get that x is equal to negative 5 halves. For 2x minus 5 equals 0, we'll just add 5 to both sides instead. So 2x this time is equal to positive 5, but then still just divide by 2, and we'll get that x is equal to 5 halves. So just like before, notice that when we have a difference of squares, your two answers are opposites of one another. In this case, negative 5 halves and positive 5 halves. Okay, so let's go ahead and look at our next example. We've got x squared plus 12x plus 27 is equal to 0. We're looking for a greatest common factor first, and there isn't one here. They don't all have variables, and there's only a 1 in front of x squared, so no GCF to worry about. Notice that it's also 3 terms, so we're not going to be using the same type of factoring that we've done on the last 4 problems. Remember, anytime you have 3 terms is where you set up your x and use that to help you factor. So let's go ahead and do that now. Remember, step 1, we'll take a times c, 1 multiplied by 27 is 27, and then copy down your b values, so copy down 12 at the bottom of the x. So we need numbers that multiply to be 7 and add to be positive 12. If you need to, go ahead and list those numbers out, but with a little bit of trial and error, you can probably figure out that that's going to be positive 3 and positive 9. Next, we'll go ahead and take our number that's in front of x squared and put that above each of our numbers in the x. Because it's a 1, there's nothing we can do to simplify. We'll go ahead and just copy down what our two factors are going to be. So from the left side, we have 1x plus 3. And from the right side, we have 1x plus 9. Now we're ready to go ahead and use the zero product property. So we'll start by taking x plus 3 and setting that equal to 0. And then taking x plus 9 and setting that equal to 0 as well. For x plus 3, we'll go ahead and subtract 3 from both sides. That'll tell us that x is equal to negative 3. And for x plus 9, we'll subtract 9 from both sides. And that'll tell us that x is equal to negative 9. Okay. We have one more example on this page of the notes, then we've got a few more examples on the next page to worry about as well. So for this example, we've got 3x is equal to x squared minus 70. We need to first get our equation to equal 0. So remember, if it's not already, make sure that you've got it equal to 0 on at least one side of the equation. And since x squared is already a positive coefficient, a positive number in front of it on the right side, let's just leave that where it is. And so let's worry about the 3x then, and let's go ahead and subtract 3x from both sides of our equation. That'll mean the left side of the equation is now equal to 0. And on the right side, we'll just list each of our terms separately. Since the minus 3x has nothing to combine with, it'll just go in the middle of our other two terms. So it'll be x squared minus 3x minus 70. At this point, we're ready to go ahead and start trying to factor. Again, the number in front of x squared is a 1, so there's nothing we can do to factor out a greatest common factor. And once again, it has 3 terms, so we can probably go ahead and just set up our x. So then we'll start by taking a times c. 1 multiplied with negative 70 is negative 70. And then a negative 3 is going to be what we'll put underneath. Now for 70, a very easy pair of numbers to think about would be 7 and 10. And really, those will work as long as we make the 10 negative, because 7 plus negative 10 is negative 3, and obviously multiplying is negative 70. Next, let's take our number in front of x squared and put that above each of our terms. Again, nothing we can do to simplify, so let's go ahead and write what our factors are going to be. So that's going to be 1x plus 7, and then 1x minus 10. Now, even though the equals 0 is on the left side, you can move that around however you want to. I'll just go ahead and move it over to the right side, and we'll go ahead and continue solving from there. All right, so setting x plus 7 equal to 0 first, and then x minus 10 equal to 0 second. And then we'll go ahead and solve with each of our equations. So for the first one, subtract 7 from both sides, and x is going to be equal to negative 7. For the second, add 10 to both sides, and we'll get that x is equal to positive 10. Okay, so there's our first few types of factoring. We still have a few left to talk about. If you remember, there was at least a couple more types of factoring we saw back in Unit 8 that we have not seen yet today. So let's look at a few more examples. I think we've got 4 more to take a look at, and these are going to be important because they are different from the ones we've just worked through. So don't think that you'd be good to just start working on homework or anything at this point. We do have a few more examples left to look at, which are going to be different and ones that you need to know. The first one is going to be this right here. We've got 3x squared plus 9x minus 12 is equal to 0. So already equal to 0, that's good for us. Now let's go ahead and see if there's a greatest common factor. And in fact, both 3x squared, 9x, and minus 12 are all divisible by 3. So if we divide them all by 3, it's going to be 1x squared. Then our next term is going to be plus 3x. And then our last term is going to be minus 4. All of that equal to 0. So now, with what's left inside the parentheses, x squared plus 3x minus 4, we have no more greatest common factor, and we have 3 terms. 3 terms tells us to use the x, and let's go ahead and do that now. So 1 multiplied by negative 4 is negative 4. Copy down your 3 underneath. So numbers that multiply to be negative 4, add to be positive 3. Those should be pretty easy to find. That would be 4 and negative 1. Next, we'll take our 1, which is in front of x squared, and put it above each of those values. So now let's see if we can simplify. Obviously, nothing we can do. So let's go ahead and just copy down what our factors are going to be. So 1x plus 4 and 1x minus 1. Notice that greatest common factor I've copied down as well, and that was the number 3. So now we'll go through and set each of our factors equal to 0. So 3 equals 0, x plus 4 equals 0, and x minus 1 equals 0. Obviously, the first one isn't going to make any sense. 3 can equal 0, so we'll just get rid of that. For the next one, we'll just subtract 4 from both sides to get that x is equal to negative 4. And for the last one, we'll add 1 to both sides to get that x is equal to positive 1. Okay. For our next example, we've got negative 20x minus 60 is equal to negative 5x squared. And so notice that it's not equal to 0, so we need to get it set equal to 0. We can do that either by moving the terms on the left over to the right, or taking our 1 term on the right and moving it over to the left. In fact, let's just move 1 term instead of the other 2. So let's start by just adding 5x squared to both sides. So on the right side now, our equation is going to be equal to 0, which is good. That's what we would have wanted. And on the left side, each of our terms are separate. There's nothing we can combine, so we'll just list them separately as 5x squared, a minus 20x, and a minus 60. All right, at this point, it's time to look for a greatest common factor. And in fact, there is a greatest common factor because 5, 20, and 60 are all divisible by 5. 5 divided by 5 is 1, so 1x squared. 20 divided by 5 is actually 4, so minus 4x. And 60 divided by 5 is 12, so minus 12. And then don't forget your equals 0. So now, with what's left inside the parentheses, we need to go ahead and set up our x. And we'll start by taking a times c. 1 multiplied with negative 12 is negative 12. Copy down your negative 4 underneath. And again, it shouldn't be too hard to find those two numbers that multiply to be negative 12 and add to be negative 4. Those would be negative 6 and positive 2. If you're not sure, remember you can always go back and make the list, and that works as well. Next, we'll go ahead and take that leading coefficient, which is a 1, and put it above each of those two numbers. Now, since it's a 1, obviously you're not going to be able to simplify, so your two factors are going to be 1x minus 6 and 1x plus 2. All of that is still equal to 0. So now we'll go through and set each of our factors equal to 0, starting with 5 equals 0, then x minus 6 is equal to 0, and then finally x plus 2 is equal to 0. Now, obviously 5 can equal 0, so we'll skip that. For the next one though, x minus 6 equals 0, we'll add 6 to both sides. That'll give us x is equal to 6. And for the last one, subtract 2 from both sides, and that'll give us that x is equal to negative 2. All right, so two more examples to take a look at, and then I think we should be good for this section of the notes. So in this next example, we've got 2x squared plus 3x minus 5 is equal to 0. So it's already equal to 0, so that's a good start. Next, we'll try to factor in a greatest common factor, but unfortunately, 2, 3, and 5 are not divisible by the same number. There are 3 terms, so we are still going to use our x. In fact, we are ready to go with that right now. So starting with taking a times c, 2 multiplied with negative 5 is negative 10. And then we'll copy down our b value, so copy down our 3. So we need numbers that multiply to be negative 10 and add to be positive 3. Those two numbers should be positive 5 and negative 2. Now we'll go ahead and take our 2, which is our leading coefficient, and we'll put that above each of our two terms. On the left side, 2 and 5 are not going to simplify, but on the right side, 2 and negative 2 are both divisible by 2. 2 divided by 2 is 1. Negative 2 divided by 2 is negative 1. So then to write our two factors, for the left side, that would be 2x plus 5 is equal, or 2x plus 5, and on the right side, 1x minus 1, all of that is equal to 0. And now to solve, we'll just set each of our factors equal to 0 using the zero product property that we talked about in 10.1, and now we just have to solve them both. So for the first one, just subtract 5 from both sides. 2x is equal to negative 5. Then divide both sides by 2 to get that x is equal to negative 5 halves. For the right equation, x minus 1, we'll just add 1 to both sides, and pretty quick with that one, just one step, we'll get x is equal to positive 1. All right, so one last example for us to take a look at, and it should be pretty similar to the one we just did, with, I think, just one extra step at the beginning. Let's take a look at it right now. So we've got 12x squared minus 45 is equal to 12x. So notice that we do not have our equation equal 0, and we would probably just want to move one term instead of 2. So let's just subtract 12x from both sides of our equation. That'll make the right side of our equation equal 0. And on the left side, since they are all separate, we'll go ahead and just list them separately. So 12x squared, a minus 12x, and a minus 45. Next, we'll go ahead and look for a greatest common factor. And in fact, 12, 12, and 45 are all divisible by 3. 12 divided by 3 is 4, so 4x squared. 12 divided by 3 is also 4, so minus 4x. And 45 divided by 3 is 15, so minus 15, and then that's equal to 0. So now, with what's left inside the parentheses, we no longer have a greatest common factor. We do have 3 terms, so we'll use our x method 4 multiplied with negative 15 is negative 60. And then negative 4 is what we'll put underneath. For 60, an easy pair to think about would be 6 times 10. And for it to be negative 60 and negative 4, just make it a negative 10. Next, we'll go ahead and take our number that was in front of x squared and put it above each of those two numbers. So we'll put a 4 above both the 6 and the negative 10. And now let's look to see if we can simplify. For 4 and 6, those are both divisible by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. Next, for 4 and negative 10, those are also both divisible by 2. 4 divided by 2 is 2, and negative 10 divided by 2 is negative 5. So now let's go ahead and write what our factors would be. We'd have 2x plus 3 using the left side of the x, and then 2x minus 5 using the right side of the x. Don't forget about the 3 that was technically in front of that parentheses, and everything is still equal to 0. All right, so now we're ready to use zero product property, starting with our 3 at the very beginning, and the 2x plus 3, set that equal to 0, and finally the 2x minus 5, set that equal to 0 as well. For the first one, and you've probably picked up on this, anytime it's just a number, you might even be able to start skipping this step, but obviously 3 can equal 0, so we're done there. For our next one, we'll go ahead and subtract 3 from both sides. So 2x is equal to negative 3. Then divide both sides by 2. And x is going to be equal to negative 3 halves. And then finally, for our last equation, we'll go ahead and start by adding 5 to both sides. So that'll be that 2x is equal to 5. And then go through and divide both sides by 2. And we'll get that x is equal to 5 halves. All right, guys, so that is it for this section of the notes. Obviously, this pulls together a couple of different ideas. It obviously has a lot to do with what we saw in Unit 8. So if you were not very comfortable with Unit 8, you might want to go back and start looking over some of that stuff again, because obviously factoring is going to be important in this unit as well. We also used a lot of zero product property. Obviously, that was why we did zero product property first in Section 10.1, as we did a lot with it in Section 10.2. Now here's the thing, not every quadratic is going to be factorable, so we're going to need some other methods that we can use to solve. And we'll start to look at those in the next section. In Section 10.3, we'll look at what's called solving by square roots, and that'll be our second method that we can use that will work when sometimes the equation is not factorable. Until then, have a great rest of your day.